Here is an example of how to determine limiting reagent. In this particular problem, the statement gives you have 60.5 grams of calcium chloride, and that is going to be reacted with 97.1 grams of sodium carbonate to produce calcium carbonate and sodium chloride. So our two reactants in this case is going to be calcium chloride and sodium carbonate. All right, so let's go ahead and write the reaction down for that. It's just looking for the limiting reagent. Let's focus our attention there. So the reaction, based on the wording, should be what I have on the screen here. But hopefully, as you write this stuff out, double check to make sure that reactions are balanced or equations are balanced. In this case, this is Na2, sodium carbonate. But over here, sodium chloride only has one Na. To balance Na, you need a coefficient of 2 in the front of sodium chloride here. By doing so, you'll give Na a 2, but that 2 will also get distributed to calcium chloride, which will make it Cl2, which matches what we have on the left side here, which is Cl2, and then we have 2Na. And then the calcium is just 1, which is just 1 on the left side, and then carbonate, CO3, we just have CO3 on the right side. So this one's not too hard to balance, okay? So again, the first line I have for you here, we need to focus on the left side because you're looking for the limiting reagent. And then this particular reaction that I have dropped for you, it is not balanced. Because not balanced is whack. So you should always, good habit, double check to make sure equations are balanced before you proceed with any sort of stoichiometry or limiting reagent problems. All right. So let's go ahead and balance that. As I mentioned before, for this one, it's not too bad to balance. So just put a 2 in front of sodium chloride, and that should take care of everything. So here's the first step I have done for you. Again, this is just one perspective to look at these types of limiting excess reagent. I'll go ahead and convert 60.5 grams of calcium chloride to moles of itself. By doing so, you essentially just go through this first step, which is just molar mass. So the molar mass for calcium chloride, if you need to bust out a periodic table and make sure that you add up the mass of 1 calcium and 2 chloride, it should give you about 110.98 grams. Okay. So notice here, grams of calcium chloride is going to cancel out, and the only unit left over is moles of calcium chloride. So if you do the calculator work, you should get about 0.545 moles of calcium chloride, around 3 sig fig, because the original problem has 3 sig figs in the statement. 60.5 is 3 sig figs, and 97.1 is also 3 sig figs. But that's not really the important part here. The important part is to figure out which is the limiting reagent. All right. So the next thing you should do is also convert the mass given for sodium carbonate. So you're given 97.1 grams of sodium carbonate. So I can go ahead and convert the 97.1 grams of sodium carbonate to moles of sodium carbonate, just by, again, going through the molar mass of that same substance, okay? So start with the starting point, which is given in the statement, convert grams of sodium carbonate to moles of sodium carbonate. By doing so, you'll get moles of sodium carbonate. But the thing you should pay attention to here is how to interpret these two outcomes that I have just calculated for you. So equivalent 6.5 grams of calcium chloride is essentially 0.545 moles of calcium chloride. 97.1 grams of sodium carbonate is 0.916 moles of sodium carbonate. Now, what you notice here from the balanced reaction, the ratio between the two reactants, reagents on the left side here is a 1-to-1. So if you look at the balanced reaction, there is no coefficient in front of calcium chloride, and there's also no coefficient in front of sodium carbonate. So we can assume that both of these coefficients are 1. So that's where the statement on my screen comes from, where my cursor is on the bottom. It says from balanced equation, the ratio between calcium chloride and sodium carbonate is just a 1-to-1. Therefore, that ratio must stay the same throughout the whole entire problem. So in the second row here that I have for you, it says the given moles. We essentially just took grams of calcium chloride and we convert the moles. And then we also took grams of sodium carbonate and convert the moles. And these are the two outcomes that we get where my cursor is. You have 0.54, and then here you have 0.916. But if you think about it, the ratio here is 1-to-1. So therefore, if you're given 0.545 moles of calcium chloride, you only need 0.5 0.545 moles of sodium carbonate because the ratio must remain the same. So whatever number here is on the left side for this problem must equal to the number on the right side. So the bottom here is what you essentially, um, need. Okay. Because for every 1 mole of calcium chloride, you need 1 mole of sodium carbonate. But you don't have 1 mole here. You only have 0.545 moles of calcium chloride. So you only need the same amount, 0.545. But you notice here, this I have here, this is what you need. But if you go to the work that we calculated earlier, this is essentially what you have, though. That's how much you're given. You don't need all that, though. You only need 0.545 moles of sodium carbonate, but you're given more than what you need. So the way I think about it, because you're given more than what you need, sodium carbonate is your excess. Okay. And the question not looking for excess, but if you know your excess, then the other by deduction would have to be your limiting. So in this case, calcium chloride would be your limiting reagent. Okay, so you have way too much sodium carbonate. You only need 0.545 and you have 0.96 moles of sodium carbonate. Okay, the second way to think about this problem is to go ahead and do stoichiometry. All right. So first, I'm going to go from mass to moles. So similar to the last process, I'm going to start with calcium chloride, and then I'm going to go to moles of calcium chloride. So grams here will cancel out. The molar mass of calcium chloride, again, is given in the last slide. We just carry that over here. And here you have 0.545 moles of calcium chloride. Now, here you have to recognize, though, once you know the mole of calcium chloride, you can use your balance equation and find moles of sodium carbonate that you need by doing mole to mole ratio. Okay, so I'm going to take the answer in this first line here. I'm going to carry that down to here. So I'm going to start now with moles of calcium chloride, but I don't want moles of calcium chloride. I want to know how many moles of sodium carbonate I need. So I'm going to put moles of calcium chloride there. That's my starting point, the answer from the previous step. And I want to cancel out the moles of calcium chloride here. And then from the balance equation, we know the ratio between calcium chloride and sodium carbonate is a 1-to-1. Again, no coefficient. So that's where these ones come from, where I'm circling with my cursor. That's a 1-to-1 ratio. So now by doing so, again, we have 0.545 moles of sodium carbonate, which is consistent with the last slide. So if you need to go back to this last slide and look at the bottom, this is how much you need, okay? But now we can take moles of sodium carbonate and we can take moles and go to how much mass, aka grams of sodium carbonate we'll need. So you know you only need 0.545 moles of sodium carbonate. So there's your starting point now. So what I've noticed, in case you haven't noticed, I've done each step individually and I just carry the answer from the previous step as my starting point in the next step. Okay, so here's 0.545 moles of sodium carbonate, which is the answer from the last step. I want to start with that. But now that I know how many moles I need of sodium carbonate, I can now just go from mole to mass. So there's the moles of sodium carbonate canceling out. Oh, I just noticed I forgot a 2 subscript here in the Na. So please add a 2 there. That was a typo error. Okay. And then from there, from this step, you can find how many grams of sodium carbonate you'll need. So essentially, if you do the calculator work here, you know that you need 57.8 grams of sodium carbonate. Okay. But this is how much you need. But in the problem, though, it gave you 97.1 grams of sodium carbonate. So you only need 57.8, but the reaction gives you 97.1. So you have way too much. Okay. Because you have way too much, that would imply that it's the excess. Therefore, by deduction again, the limiting reagent in this case would be calcium chloride. Okay. I hope that helps in terms of using different strategies to determine limiting or excess reagent. All right. Stay nerdy. Don't be whack.